Hello students, I am Ekta. Previously, you have learned about the surface area of combination of solids. Today, in this part, we are going to see the volume of combination of solids. In this previous session, we have discussed how to find the surface area of solids made up of a combination of two basic solids. We learned how this knowledge has practical application such as calculating the paint needed for a truck container or determining the wrapping paper for a unique gift box. Now, let us consider a scenario involving volume combination where understanding the amount of space an object can hold becomes crucial. Think about a capsule. It is not just a simple shape. It combines the features of a cylinder and two hemispheres. To figure out how much medicine it can hold, we need to calculate the combined volume of these shapes. Just as architects design buildings and engineers create structures by combining volumes, we are going to dive into the world of combining volumes to solve real-world problems. Learning outcomes. After the completion of this lesson, you will be able to break down intricate three-dimensional shapes into simpler components, facilitating the calculation of their combined volumes. Compute the total volume of composite figures by summing up the volumes of their individual components. Apply volume calculation to real-life situations, including container design, architecture, and engineering to optimize space usage. Keywords: combination of volumes, intricate shapes, assembly, disassembly, component shape. Now we will solve a problem. A pen stand made of wood is in the shape of a cuboid with four conical depressions to hold pen. The dimension of the cuboid are 15 cm into 10 cm into 3.5 cm. The radius of each of the depression is 0.5 cm and depth is 1.4 cm. Find the volume of wood in the entire stand. Solution: given the dimension of the cuboid is equal to 15 cm into 10 cm into 3.5 cm. The radius of the depression cone is equal to 0.5 cm. The depth height of the depression cone is equal to 1.4 cm. In this question, they have asked us to find the volume of the entire hood after depression. So, we should subtract the volume of depression cone to get the volume of the hood. We know that the volume of the cuboid is equal to L into B into H. Now, substitute the values in the formula. We get is equal to 15 into 10 into 3.5 is equal to 5 into 35 is equal to 15 into 35 is equal to 525 centimeter cube. Therefore, the volume of the cuboid is equal to 525 centimeter cube. Now, find the volume of the depression, that is cone, and we have here 4 such depressions of same dimensions. Volume of the cone is equal to 4 into 1 by 3 into pi r square h. Now, by substituting the values in the formula, we get is equal to 4 into 1 by 3 into 22 by 7 into 0.5 into 0.5 into 1.4. Is equal to 4 into 1 by 3 into 22 into 0.5 into 0.5 into 0.2. By cancelling and multiplying the terms, we get is equal to 4 into 22 into 0.5 into 0.5 into 0.2 by 3. Then we get is equal to 1.46 centimeter cube. Therefore, the volume of the 4 depressions in the wood is equal to 1.46 centimeter cube. Hence, the volume of the entire wood stand is equal to volume of cuboid minus volume of 4 depressions cones is equal to 525 minus 1.46 is equal to 523.54 centimeter cube. Now, let us solve another problem. A solid iron pole consists of a cylinder of height 220 cm and base diameter 24 cm, which is surmounted by another cylinder of height 60 cm and radius 8 cm. Find the mass of the pole given that 1 cm cube of iron has approximately 8 gram mass. Solution. In this question, they have asked to find the mass of the pole. So, in this case, we should find the volume of each cylinder and add the 2 cylinders' volume to get the entire mass of the pole. Given the radius of larger cylinder R is equal to 12 centimeter. The height of larger cylinder H is equal to 220 centimeter. The radius of smaller cylinder R is equal to 8 centimeter. The height of smaller cylinder H is equal to 60 centimeter. We know that the volume of cylinder is equal to pi r square h. Now, substitute the values of larger cylinder in the formula. Is equal to 3.14 into 12 into 12 into 220. By multiplying the terms, we get is equal to 99,475.2 centimeter cube. Now, find the volume of smaller cylinders by substituting the values in the formula. The volume of smaller cylinder is equal to pi r square h is equal to 3.14 into 8 into 8 into 60. By multiplying the terms, we get 12,057.6 centimeter cube. The total volume of the cylinder is equal to larger cylinder plus smaller cylinder is equal to 99,475.2 plus 12,057.6. Adding the terms is equal to 1,11,532.8 centimeter cube. Now, we will find the mass of the pole. Given that 1 centimeter cube of iron pole consists of 8 gram, 1 is equal to 8 gram, 1,11,532.8. How many grams? By cross multiplication, we get the mass of the entire pole is equal to 1,11,532.8 into 8 is equal to 89,262.4 gram. Students, now let us summarize what we have learned today. When finding the volume of a combination of solids, calculate each solid volume separately and then add or subtract them as needed. Pay attention to units and ensure they are consistent throughout the calculations. The formula for mass is equal to density into volume. Understanding how to optimize space by calculating volumes is a valuable skill that can be applied to solve real-world problems. In real-world applications, geometry plays a vital role in solving practical problems related to design, construction, and materials optimization. Thanks for watching this video.